This session, we will discuss the March release of Mercoin's infrastructure design and construction and SRE efforts to release reliable services. First, let me introduce the presentators. My name is Iino, joined Masaki in May 2019, responsible for infrastructure and backend, and joined Melpay SRE team in February 2020 and became a tech lead for Mercoin SRE since 2021, responsible for launching the Mercoin business. So my name is Yuhara. I'm in charge of the second half of presentation. I was in charge of setting up the SRE team at the Mercoin since 2021, mainly around the network and infrastructure. This session is divided into two parts. The first half of the presentation will discuss the security and compliance initiatives required for Mercoin infrastructure. In the second half, we will discuss the overall infrastructure and our efforts to release reliable services. Let's start off by talking about the security and compliance initiatives. First, Mercoin is a company that provides a service that allows users to buy and sell Bitcoin within Mercari app. Crypto asset exchange business started on March 9, 2023. Within this session, we'll talk about the crypto asset trading service within the Mercari app with respect to Mercoin. So what is required for Mercoin infrastructure? Because crypto asset exchange systems handle financial transactions, their security and compliance are critical factors. Regarding security, crypto asset exchanges are at the risk of cyber attacks, unauthorized access, hacking. Therefore, it is necessary to have a strong information security. Regarding compliance, crypto asset trading is operated and managed in accordance with laws and regulations in each country, and therefore must comply with the laws and regulations set by FSA in each country. Proper management and advancement of deep security and compliance controls will help protect customer data and maintain the integrity of the exchange. Mercoin security regulations and requirements differ from those of Mercari and Melpay. Due to the nature of crypto asset business, it is necessary to take measures against various cyber attacks. It is also necessary to respond immediately to sudden changes in national regulations. Therefore, by separating the infrastructure, one for Mercari and Melpay, the Mercoin aims to reduce the number of points to be protected and to make it compact enough to withstand sudden changes in regulations. The security standards and incident management required for crypto asset exchange system should be high, so ideally the level will be met by all companies, but it is not easy to achieve it immediately. For example, if the infrastructure is not separated and the Mercoin is co-located with infrastructure of Mercari and Melpay, it will have a significant impact on the system management system and operation of Mercari and Melpay. So this is to prevent incidents occurring at the Mercari and Melpay from propagating to Mercoin, and conversely to prevent attacks on crypto asset exchange system, which are more likely to be attacked from spreading to Mercari and Melpay. In the future, we hope all companies will meet the same security and compliance standard. Specific examples of separation in the production environment are explained here. So first, Google Workspace is separated for Mercoin and Mercari, Melpay. For the existing Mercari.com, we have a Google Workspace called Mercoin.com. GCP organization also exists in each workspace. However, billing account uses a common account. This is to apply the terms and conditions that Mercari has with Google to Mercoin as well. To use a common billing account across multiple GCP organizations, GCP multi-billing is used. This feature can be applied up to 5 organizations. The number of organizations is limited and should be carefully considered and applied. The developer's incorrect configuration can create risks. Security should be guaranteed even if developers are not aware of it. Security should be maintained even when the new microservices are added. Therefore, we have decided to aim for secure by default throughout Mercoin. At Mercoin, our goal is to create and maintain secure state from the beginning. Use the security function and settings that the Mercoin group has built and our strength in creating from scratch. In addition, by minimizing the number of usable settings from the beginning rather than added in the security settings later, developers are prevented from setting up dangerous settings without their awareness. Partial exceptions are allowed as needed. By applying a GCP's organization security policy to the entire GCP organization, service will increase. A new GCP project cannot be configured to be dangerous from the start. Since the inception of the project, we have worked with security team to review all organization security policies one by one and apply the policies at the organization level. During the review process, the policies are created with reference to Google Cloud Security Foundation Guide provided by Google and the recommendation of the CIS benchmark. Here is an example of one of the policies we have adopted. Prevent the use of SSH keys embedded in a DCE metadata. Bootloaders and OS tampering are also prevented. The granting of editor privilege to GCE's default service account is also restricted. It also restricts the public disclosure of the GCS. Also, IAM, we have a custom browser role with a minimum privileges, and we assign roles to each team at the GCP folder level tailored to each team. For example, SRE team looking at the entire production has broader minimum privileges enabled, and the microservice team has a minimum privileges on the GCP folder for the team that bundles the microservice they're responsible for. When authority promotion is required for operation, in-house authority promotion tool called Carrier is used for temporary authority promotion. Carrier will also be discussed later in the session. In addition, items that cannot be covered by the security policy are added to the PRC section and are checked when new services are released and on a regular basis. The Mercoin team needs to take on ownership of the Mercoin infrastructure from a security and compliance perspective. Mercoin Group has SRE teams for each of its products. Mercoin SRE, Melpay SRE, and Mercoin SRE. Each SRE team develops and operates infrastructure and supports microservices to ensure stable operation of the products for which they're responsible. In addition to the SRE for each product, there's a platform team that develops and operates the infrastructure. They are the owners of the entire infrastructure. To compare with Mercoin SRE, so we will first explain Melpay SRE. In Melpay SRE, SRE supports the development team and manages the development of the system commonly used in Melpay. The platform team is the owner of the entire infrastructure while developing and operating the infrastructure component. On the other hand, in Mercoin, the basic role of SRE is the same as Mercoin and Melpay, but SRE is the owner of the entire infrastructure. SRE is responsible for approving the outsourcing, the development and operation of infrastructure components to the platform team. In this way, people only belonging to the Mercoin organization only manage the Mercoin system. At Mercoin, All customer data and server resources, including backup, are located in Japan. Handling in Japan facilities compliance with the Japanese laws and regulation is secured. It also clarifies the protection and guidelines for customer data and facilitates management and security measures. For this reason, GCP regions are restricted to Tokyo and Osaka. However, the function that GCP provides globally only do not specify a region. By applying resource location in the organization security policy to the entire GCP organization, number of the service increases, and even the new GCP project is created, it is not possible to create the resource outside the country from the beginning. However, it is possible to allow the creation of the resource in other regions on a project-by-project basis if necessary. Since the policy is managed by SRE, setting exceptions require SRE permission on the system. Here is a summary for the first half. Mercoin has built a unique infrastructure to ensure the safety and trust of our customers. It is separated from Mercari Group, and the Mercoin team manage the infrastructure. The system is operated in Japan and provides a secure trading environment. Furthermore, the design of the system itself ensures the safety without any special attention from developers. So now I'd like to discuss the overall picture of Mercoin's infrastructure and our efforts to release the reliable services. So the first, let's take Mercoin's architectures. All microservices are based on GCP and run in common GKE cluster. Microservices are layered architecture with a gateway service that accepts the request from internet, auth token service that handle authentication, API service that acts as a BFF in front of each backend service, and the various backend services that handle business logic. The workload of each microservice runs on common GKE, but the databases and other resources used by each microservice are divided into separate projects, which are managed by a team of backend engineers who are the service owners. Microservices are divided into different projects, but in terms of networking, shared VPC configuration allows resources belonging to VPC, GKE, memory store, GCE to communicate within common VPC, even the projects are separated. The host project of the shared VPC is positioned as a hub of the network, so the host project can be managed by the network administrator to control communication within shared VPC via VPC firewall to control the communication to outside the world with Cloud NAT, and to manage private domain within VPC with Cloud DNS. In line with the secure by default policy, Mercoin uses the default deny configuration for the VPC firewall to allow necessary communications. At Mercoin, GKE cluster is divided into several clusters depending on the use. So that cluster for consumer app and a cluster for all others. For example, there is a cluster for the self-hosted runner of the GitHub Action, which is managed by the company, and a cluster for internal operation tools.
And even when the communication is needed via a cluster, shared VPC allows the communication within the VPC using shared VPC. And even for Mercari, independent organization and VPC is available that is separated completely from Mercari's organization. But there are cases where Mercoin need to integrate with the Mercari services. For example, the Mercari user ID and Mercoin user ID to be mapped. The Mercari's user ID can be captured from Mercoin. And in this case, the VPC is separated. Therefore, generally, the service endpoint is published in the internet, and you could access through the internet, or different VPC is connected by using VPC peering. But either way, the design to communicate with the network will become complex. So as the Mercoin group, as a way to connect the different VPCs between the different companies, we use Private Service Connect. With Private Service Connect, the subjective service is connected to the project that is made public using the service attachment. And by limiting the opening, it allows the connection to the designated project and allows secure access. VPC peering is not necessary, and we're able to integrate and communicate with the Mercoin services very easily. And next, I would like to talk about some of the design related to the Mercoin GKE cluster. Mercoin GKE cluster is a private cluster and limited disclosure public cluster. And private cluster does not have an external IP address, meaning that it only has the node structure that only has the internal IP address within the VPC. And the Kubernetes API server is provided using the internal IP address within the VPC. And so from the host within the same node or the same VPC, then it could be communicated by closing to the network. And for the maintenance and operation, if you want to access from the internet to the Kubernetes API server, the public endpoint is specified or limited to the specific IP address. And because the node does not have external IP, the external communication, it goes through a cloud NAT. And there's the network policy as one of the GKE function. All the microservices are using one common cluster and have multi-tenant in order to control the microservice and namespace communication. The network policy is enabled, and in default, all is denied. And in order to allow the access to necessary microservice access, the network policy is updated using whitelist. And next is Cloud DNS for GKE. We don't use Kube DNS, and Cloud DNS is enabled. And in the DNS scope, we have two different modes, cluster scope and VPC scope. And in Mercoin, we use VPC scope. And by using VPC scope, the DNS name within GKE can be transmitted to VPC, and you're able to pull the specific Kubernetes service name from the host directly that's outside the cluster. And by doing so, we can access the microservice without going through the ingress. And this is just a precondition, and this is limited when the communication is allowed through a VPC firewall network policy. And there is the function that allows Google Group Kubernetes role binding is enabled, which is called Google Group for RBAC. And by integrating with user management with Google Group and worker identity is integrated to Kubernetes service account, GCP-IAM service account, and that realizes keyless structure. And we can use add-on that is prepared by GKE for Istio, but we don't use add-on. And with add-on, it does not allow the specification of the versions that's available is sealed, or it cannot coordinate the functions or configuration that we want to use. And Mercoin, in order to set the versions of the functions that we want to use, we use user-managed Istio. And the use case of Istio is to manage the traffic, mainly for canary release, in case of a canary release of 1% traffic migration. And next is the overview of the development and operation of Mercoin microservices. All the microservices are running within the common GKE cluster, and it is a multi-tenant structure that's separated using namespace, and the GPCP is separated for project. And I would like to introduce you to how this is operated. For each microservice, we have designated the development team, and the team has the ownership to do the operation as well. With this example, Service A team is managing the resources for the Kubernetes namespace A and the A space spanner and pub sub that's within GCP project. However, specialized knowledge and resource management is required to build and operate these. And in a limited member and schedule, it's very difficult to provision everything from scratch. And there's a possibility that the configuration does not meet the expectation of Mercoin. As SRE, we want to promote the team's development and also allow the provisioning that is defined by the Mercoin. We provide abstracted module, and by using this, the developers don't need to do the configuration one by one, but instead they can provision what is already standardized. To be specific, things like spanner or PubSub types of GPC resources are not the only thing, but also in order to do incident management on call, the PagerDuty that is used by Mercoin, or GitHub for code management, and the data logger that's used for monitoring, and Kubernetes resources are defined by Terraform, and the resource that's related to Kubernetes workload can be abstracted using COUE. We'll be more specific. As an example of the module that's used in Terraform, depending on the use cases, we have several types. The one on the top is the microservices starter kit, and this is a kit that is used when the developer develops a microservice. Things like GCP project or Kubernetes namespace can be created, and the required IAM setting that are required are included. And microservices teams kit is provided to the service team, and it is used for member management for a Google group, or IAM setting that's granted to that team, or a PagerDuty setting that's used in on-call, or a GitHub Teams management in GitHub are centrally managed. Microservice spanner kit covers spanner instance or database configuration, and also database backup or spanner autoscaler. This is an autoscaler system that can scale out the instance depending on the instant load. By including those necessary requirements, this kit can address this. Microservices SLO kit, depending on the microservices service level or SLO, this is a module that allows a data log monitoring setting, and it is made so that monitoring does not be created for each one. And similarly, for Kubernetes resources, developers need to manage a lot of YAML, and it becomes cumbersome, and we want to simplify this and lower the burden. So we use an open source language called Q and do the abstraction. And compared to YAML, we can reduce the code significantly. And for things like STO, by introducing those new technology, we can lower the burden on the developers. And as Mercoin, we are able to create the workload while having full control over the security and availability. Q itself is not a major language yet, so you might be interested in Q. And if you're interested, we have introduced this in Mercoin blog before, so please refer to this blog. Up to this point, by abstraction, how the developers are easily able to develop and operate microservices were presented. On the other hand, if you do too much abstraction, if you wanted to do a slightly different configuration to the others, it will not be able to address it. It might not be easy to use, or you might have to change the standardized module itself and cause the cost to be higher in some cases. So therefore, Mercoin, not just Mercoin, but as the Mercoin group, we provide kits to do the abstraction, but at the same time, we have the freedom to allow the developers to use Terraform and do the microservice development and operation. And by doing so, the resources that are not standardized can be provisioned to the production environment. And so from the perspective of Mercoin security and availability, the recommended configuration or the configuration that should be avoided in order to fulfill that Mercoin's policy we use conf test to validate the codes on Terraform and Kubernetes. One example is the Terraform module that is required to connect to shares VPC, but we want to limit that so that only the allowed services can be connected. So we will check that, and when VPC firewall is configured using Terraform, we recommend the logs to be outputted for audit purposes. And in Kubernetes, we are validating whether the container is in privilege mode or whether the host network is not being used in manifest. When the operation starts, we may have cases where emergency operation is required in order to address issues. And in order to change the infrastructure as response, we can change the code and go through CI/CD, but that takes too much time until restoration. And it's the same with getting the IAM privilege. When we use Terraform code to go through CI/CD, the privilege will take a lot of time to be granted. By using this clutch tool, we provide one-time privilege with limited time can be given by receiving approvals. Basically, SREs or developers don't have any right to make changes to the production environment, and when it is needed, they will request for that right using clutch. And once the SRE approves it, they will receive that right. And once the expiry date is expired, it automatically goes away and it could be revoked. So there's no way of forgetting the rights being erased, and it could be safely managed. Lastly, a summary. Mercoin, from a security and compliance structure, Mercury is completely independent as a GCP organization. Mercoin's microservice uses multi-tenant using common GKE clusters. And from a security perspective, by using network policy, we are completely separated from other tenants. And developers have the ownership of the microservices, and from the SRE, by offering the tools where the infrastructure is abstracted, we have promoted the development and operation of the services. But on the other hand, it's a challenge. It's because we have more abstracted tools, we have higher burden or higher cost around learning this and higher burden on the developers. Also, therefore, we needed a simpler interface to solve the issues. And to address those challenges, we want to introduce many technologies to make improvements. Thank you very much for your attention today.